Hello everyone. All right, so today we're going to finish higher level topic 10.3, and we are going to look at pace of speciation, and this should be rather quick. So let's look at the term speciation again. So if you recall from the previous video, speciation is the evolutionary process that gives rise to a new species. So here we're going to explore the pace at how this speciation process happens. So if you remember Darwin, he was a strong believer of gradualism, and that just means that you have some form of continuous change at a constant evolutionary pace over time. So here you see the original ancestor species. And then you see that slowly over time, and this could be millions of years, this ancestor just is no longer there, right? Because it has branched out into different species. And now you end up with two completely different species that just share a common ancestor. So this is gradualism, and we see this in the evolution of the horse and the evolution of the elephant, and even in hominid evolution. In this particular, model, there are a lot of intermediate forms, and then these intermediate forms, sometimes when they die, they turn into fossils, and many of these transitional fossils have been found. So there is some evidence for this type of phyletic gradualism as a pace for evolution. But we also know that recently in the 1970s, a new model and pace of evolution was proposed. And Stephen Jay Gould proposed this model of punctuated equilibrium. And this just means that species remain stable for long periods, and then they might at some point during their evolutionary history undergo abrupt and rapid change, which is speciation, of course. So here we see the common ancestor, and in this particular model, you see that something happens here, and this change here, this abrupt change, it's usually something that happens to the environment. And then you see a speciation. You see a new species here form. And then you might have a long period here with no change. So it could be very stable thereafter. The abruptness of this rapid change can vary, right? So here you see this other branch, right? It took longer for this other branch to develop into this particular species. And then that species remained constant over time. So this view here is supported by the general lack of transitional fossils for most species. Although sometimes a fossil just doesn't form because the conditions are not right for these fossils to form. Okay, so for example, this particular species here, you wouldn't see any form of a transitional fossil, right? Because there was a short, rapid change, perhaps millions and millions of years ago. There is no fossil evidence here. And then that species has undergone a long period of stability. So no transitional fossil there. So here is the model represented in a graph. So we see phyletic gradualism here. So you see that species arise gradually over time via those cumulative changes. And here you see punctuated equilibrium. So you see that there are prolonged periods of no change, and then there's rapid change of evolution, and then you get the onset of a new species. So speciation happens here, and then that new species might go with a prolonged, and it might go through a prolonged time period of no change, and then you get the speciation of a new species. Here, abruptly, and then there's going to be, again, more time with no change. So these are the two models that propose the pace of evolution. So that is it for topic 10, and that is it for 10.3.